In this video, we're going to look at polarity. To understand polarity, we first need to look at electronegativity. This is the tendency or ability of an atom to attract a bonding pair of electrons. Note these are only the two electrons in the bond between atoms. They're not any other electrons, such as non-bonding electron pairs. So you can think of this as a tug of war between two atoms for the pair of electrons in the bond. This periodic table shows the electronegativity value for each element. This value ranges from 0, the least electronegative, up to 4, the most electronegative. There is a trend in the periodic table, so as you progress down a group, the electronegativity value decreases. This is because the valence electrons are further away from the positive pole of the nucleus, because each period you go down, you're adding a shell of electrons. As you progress from left to right across a periodic table, the electronegativity value increases. This is because the atomic number increases, so there are more protons in the nucleus and more electrons around the nucleus. Therefore, the electrostatic attraction between the positive nucleus and the negative bonding electrons is greater. Now this trend is easy to remember if you remember that fluorine is the most electronegative element. Now you notice here that the noble gases do not have any electronegativity values. This is because they do not undergo any form of bonding, and therefore they're not going to have an attraction to any bonding pairs of electrons. The first type of polarity we're going to look at is bond polarity. There are two types, nonpolar and polar. So a nonpolar covalent bond happens when the two bonding electrons are shared evenly between the atoms. This means that neither atom has a partial charge. This can occur in two situations, either when you have two of the same element, such as chlorine, or between carbon and hydrogen, which have very similar electronegativity values. Polar covalent bonds, on the other hand, result from the uneven sharing of electrons between atoms. This happens when you have two different elements that have different electronegativity values. The electrons spend more time closest to the more electronegative atom. In this case here, they spend more time closest to chlorine. This generates a partial negative charge on this side of the bond, and hydrogen, which has a lower electronegativity, forms a partial positive charge. Now note, these are not full charges, they're not ions, they're just indicating a partial charge, represented by the Greek symbol delta. Partial charges create a bond dipole. This is just the separation of electronic opposing charges, so the negative on one side and the positive on the other. A bond dipole can be represented by this arrow, with the arrow head pointing towards the more electronegative region and the other end of the arrow towards the more positive partial charge. The other type of polarity you can have is molecule polarity. Now this is the polarity of the overall molecule, not just an individual bond. Again, there are two types, polar and nonpolar. So a molecule is polar if it contains polar bonds and it is arranged in a shape which can be divided into two distinct regions of charge. Now you can easily do this if you can draw a line through the molecule where you can separate the partial negative charge from the partial positive charge. So these molecules shown here are all polar molecules. Nonpolar molecules, on the other hand, can result from two different situations. The first is when the molecule contains only nonpolar bonds, so either bonds between two of the same element, or bonds between carbon and hydrogen, which have similar electronegativities. The second situation is when the molecules contain polar bonds, in which either the bond dipoles cancel out, or you cannot divide the molecule into two distinct regions of charge. So these two molecules here are examples of those. The first, carbon dioxide, you cannot draw a line to separate out the partial negative charges from the partial positive charge. Over here, with carbon tetrachloride, you can see that the bond dipoles would cancel each other out as they are evenly spaced around the carbon atom. Lastly, we will consider how to compare the polarity of two different molecules. There are two things that you need to consider. Firstly, the number of highly electronegative atoms, or the number of functional groups that contain highly electronegative atoms. Secondly, you need to look at the size of the hydrocarbon section of the molecule. So if we look at these two molecules here, you can see the molecule on the left has a greater number of atoms, or a greater number of functional groups that contain oxygen, which is a highly electronegative element, compared to this molecule here that only contains one. This means that the molecule on the left would be considered more polar.